What's going on, everybody? So we've had 2 long days. 4 a.m. we went upstairs. I went upstairs. Me and my mind went upstairs and laid down. And went to bed. It was probably 5 o'clock this morning, and then I woke up at 7:30. Maybe took a half an hour nap, but I cannot sleep. I've been too excited, and it has not been an issue. Pretty stoked to show you here what we have going on. I have it 99% done. All I have to do is go get that toggle switch that I was telling you guys about just the other day. So I'm going to set my phone up. I'm going to show you what I've been doing for the past 2 days until 4 a.m. in the morning and sleeping for like 3 hours, maybe 4 hours each day. So this is what we did. I'm going to put my phone up here. That way everybody can see what is going on here. Now, that treadmill motor is right there on the left-hand side. And I wanted to use it up on the lathe itself, but it's too big, and I got another theory for that. But this is what I made. This is what you would call a captive mandrel. The cool thing is we use a mandrel at work for the mills that I used to run before I broke back. And this all comes apart. So I got a nut, flat washer, and a split washer. And then there's a bolt in here. This bolt comes all the way out, and it's double threaded on each end. I actually turned this bolt down and threaded both ends from that bolt. That is remainings of it. So I did not have a bolt, obviously. No stores were open at 1 o'clock or so this morning. Maybe it was 3 o'clock. I don't even remember. But I had to taper the inside of this here, the end of the mandrel, at 10 degrees. And I bored it at 1/2 inch and then 1/2 inch deep. So I knew exactly where I was at, how long I would need for my counter-reactive part that would slip into it. So I turned the lathe back around with a little piece of aluminum in there and turn that down at 10 degrees also. So when that slips in there, you put your washer, lock nut, lock washer and your nut on there, and when you pull it together, it expands right here. It's slit in 4 spots across from each other's, and it allows it to swell. I drilled holes here as well to allow it to open up better. Now this piece comes all the way through to here, and this is the stop. This is basically just a large spacer. And then this is a chunk of aluminum. And underneath the aluminum on this shaft, I machined grooves for Loctite to sit on. And then when I pressed this piece of aluminum on, it would not release. Now, I did not put any Loctite on it for the simple reason my tolerances were so freaking tight. I cannot exaggerate. I actually mushroomed my end here when I was pressing them together. It was that tight. So there's no Loctite on them. It's probably got some metal aluminum shavings in the grooves itself. And then this is the pulley that was mounted on the treadmill. Now, I have that piece. Where did it go? That was mounted on this huge pipe. Now, this huge pipe is what the belt rode on. And then this would turn the belt. And there was another one of these on the back end. You can see the etchings in there that this pulley sat on, so it would get traction, it would not slip. And then there's a pin that goes in there, long story short, and the pin is stationary. There's bearings that sit in these plastic races, and the outer part is spinning the belt. So that's the pulley from the treadmill. It's got a magnet on it. I got to get the sensor mounted for that yet also, for the treadmill control unit. And here's what we're doing with this piece. So you slip that in there, put on my washer, my flat washer, put on my split washer, and put on my nut, but I don't need to tighten it up. And then this slips right into the headstock spindle here. Loosen it up just a little bit. And it's a really nice tight tolerance. See, it's starting to spin the chuck a little bit. Put that all the way up into this spindle as far as it'll go. And all I do is tighten up this nut, and that is swelling up the mandrel inside of there. I need to get a smaller wrench for this deal here. Now it really does not take much at all to hold it because the tolerances are so tight inside of the spindle, which is exactly what I wanted. It helped keep the pulley nice and straight with the motor. You can probably see where I'm going with this now. So, well, it is just literally snugged up. And now I'm spinning over my chuck. So I'll get rid of that tool. Alright, so this was that big pulley that goes on the motor. The motor shaft had a 1/2 inch reverse thread, left-handed thread. It's counterclockwise that held this on. Because of the direction that the motor spun, it would not come loose that way. The treadmill obviously did not go in reverse. So I lopped off the threads trying to put on that drill chuck for what I was trying to do earlier, and I had no way of securing this back on there. I was hesitant on cutting off this large wheel from the pulley itself because I feel like the weight here, it's quite a bit of weight. You can see it's thick. I feel like that somehow regulates the speed of the motor, like the head unit of the treadmill senses this restriction that the weight provides or offers, whatever, and that's how it adjusts for its speed. Without it, I feel like it's gonna make the motor run off like crazy, just take off on full speed, and I won't have my lower speeds. So having the threads lopped off, I was trying to figure out how I was going to attach it. And long story short, I chucked this up into my lathe chuck, and my lathe chuck is held on by 3 bolts back here. They're exactly spaced apart. So with that chucked up, I put marker up here and pencil marked where the center of the bolt was in line with my oil ports, because I know those are dead center with the spindle. Doing that, I calculated my measurements and everything to set it into a drill press. Well, it's actually a milling vise, but I'm using it on my drill press from Grandpa. And then I bored it down, well, drilled it down first with a shorter bit, and then I bored it just so it came through and I had relief. And then I got a long bit since I had the pilot already started, and I drilled all the way through for an M4 by 0.7 thread, which is the exact same thing that I had for the drill chuck. And then I put my boring drill bit back in it, well, the one I was using for the diameter, and came down so it is 10 millimeters off of the shaft. I kept all those equal. The problem with doing that is getting a tap inside of there, because your tap is roughly that long, and I did not plan that out. I was just going to figure out a way to do it once I got there. And a 4 millimeter 1/4 inch drive socket held the tap perfectly. I had to press it in. I literally mounted the tap inside my 4-jaw, and the tap had 4 cutting edges. I turned it so the jaws were not touching the cutting edges just to hold it, and I tapped the socket on. Then got it tapped, and the same exact socket holds a 2 millimeter Allen key, which is the size of the Allen that goes in here. There's one in there, and it fits in there absolutely perfect. Like you couldn't plan that better. So I don't know if you can see it or not, but there's a little Allen key dropping in right there. She is. So that's pretty stoked about that. How often you use a 4 millimeter socket anyway? So this one just got dedicated to my lathe, and if I need another one, I'll go get one. So I'm gonna get this mounted on then. Got all the Allens in there. Trying not to forget anything. So get this slipped on here. And this pulley is so tight to the shaft, you don't have to tighten these up very far. Just snug. There's no vibration coming from the motor, so I'm not really too worried about the little set screws backing out. Alright, so those are set. We'll get rid of these tools. Got the captive mandrel in there. Pulleys are on. Other thing, I don't know if you can see it. You might be able to see it in here. Well, we'll just take the phone and we'll show you. Back here, this is the old mount for the motor from the treadmill as well. And I threw a washer on the right hand side in between the mount and the bracket to take up the space that was in there. I took the corner piece from the treadmill, literally it was just the tubing that the motor was mounted to, cut the mount off of the tubing and then re-welded it on there. So I'm squared up. I know that's all square. I drilled 1/2-inch holes, and then down inside of there I used these large wood screws. That is holding the tubing down. There's only 3 of them, one here, one in the back corner, and one there. So that's all secured. Wrench for the lathe, 14mm, fits on here perfectly, like all this was meant to be. And I have the adjustability for my belt now. So we'll grab the belt, chop and weld. I'm gonna have to put the phone back up. So we slip the belt on here. So a serpentine belt, just like a car has, but super short. Pivot the motor up. And then the weight of the motor is adjusting the belt just about right. I do like to have it a little bit looser than what the weight is providing. Alright, that's tight. Belt has a nice slack. Put that tool away. And I use this as a straight edge. I used the same principle when I lined up my alternator on my rat bite there. Going off of the larger flywheel. I'm calling this a flywheel, the pulley. And the spacing is pretty equal from the first groove in to the outside of the pulley from down here also. So it's perfectly aligned right there. So that's good. None of this is even used anymore. I do have it plugged in because I was going to show you something before I put that belt on, but it's really not that big of a deal. The lathe itself here, normally you would have your power. Come on, focus. Oop, go back. Come on, focus. What the heck is going on? There it went. So you got your forward and reverse switch here. And I'm going to take the switch out and use it on the controller of the treadmill for the forward and reverse, and then you had your speed adjustment. The other thing about it is there's a high and low gear inside of here, which will no longer be needed with the adjustments through that motor speed, and it's spinning straight off the spindle already. So the high and low will do nothing. Right now I'm in neutral, despite that it's in line with the H for high, but you can hear how smooth it is. Stop it and drop it in gear. You can hear all the gears inside of there There's 4 gears in here for your high and low, and then everything else that comes down here back for the original motor setup. So I'm going to take this handle off, and I'll end up building a lever back here, or a catch, that basically forks this lever in neutral, so that way no vibration can drop it into gear while I'm using the treadmill motor. Alright, so we got that. We come over to the treadmill. Oop, we gotta plug this in this unit. I wired this myself. That should be fine, right? I don't know much about electricity, but it works. We got the treadmill unit plugged in. Cords are safely out of the way for demonstrating. This unit is going to be mounted on the wall once I get my sheet of aluminum. That is going to be my catch pan / trough, chip trough in the back, and a backsplash. So I can delete that entire backsplash, and I'll have a lot more access going on in there. So we got power up there. We're going to turn this sucker on. And it's on. We'll go to 1. And that's 1. It breaks down the speed as it sits. And I can take it down to 0.5. I feel like if I get a dial switch, I can never remember what they're called. A switch like this to control the power source yet. That will get me even slower. But the main reason behind doing this was the original motor. The original motor did not have enough torque to be turning 1/2-inch drill bits. You'd be boring a 1/2-inch hole or even larger. And with the metal gears and everything, that's all solid now, and the motor was the weak point. So that's the whole purpose behind doing all of this. It will not stop. Thank you, David. Yes. Yeah, that word. I can't say it right now. But this motor is it's not gonna trip out. It's not gonna slow down. It is just gonna rip. This is gonna be a solid machine, I feel. It's really going to rip. So I'm pretty stoked. I got one more upgrade I want to do to it yet, but that's further down the road, and I'm gonna need help doing that one. And as for the milling attachment, I did run that the other night and it worked, but I was not using the proper tools, nor there was too much vibration. My setup is not what I needed, so I have another route I'm going to go on that, and I will be milling on this lathe. The little Harbor Freight mini lathe that wished it could, and now it's doing it. Actually, I got 2 more upgrades I'm going to do yet. They make another compound not compound. Yeah, it's compound. They make another one that gives me 1 more inch, so I'll be able to never have to adjust this deal to work on larger diameter pieces up here, because you'd have to get it out of the way to get the tool past it to actually cut it. And with a 1-inch extension, I feel like that's going to give me everything I need. And then I'm limited by my center of the chuck to the bed height. But that's it, I suppose. Yeah, it's been a crazy couple days here, and I'm pretty stoked with how everything has turned out. I can't even lie. Everything turned out real nice, and I learned quite a bit building this mandrel itself. The precision of cutting the mild steel, running it super slow on this little lathe, it works phenomenal. And I have been converted to the cutting oil that Mike Chop and Weld gave me with this lathe. This stuff is phenomenal stuff for cutting mild steel. Phenomenal. I can't even emphasize the quality of appearance. Just how the bolt is the best example. Let's unplug this. I don't want to get ripped off. the finish. The quality of the finish is the word I'm looking for. I'll show you here real quick. The only downfall of this setup, the through hole that I'm actually using for this pulley in the spindle. To break this loose, first of all, just back that nut off and tap it. I can't work on longer pieces now because I'm blocking the through hole to where you could run your stock all the way through. But this spindle is so small, I think is 0.798 is the inside diameter of that spindle. So really 3/4 was my max running it through there. But yeah, the benefit of having a lot more torque overweighs that downfall. And the less noise of having this whole headstock, not having the high and low transmission gears, the noise that creates is another benefit. But the finish on this, I mean, that's been ran in through there many times now, and that cutting wheel, cool tool too, is that's the bee's knees. No joke. I've been converted, Mike. It took me almost a year to get converted on that oil, but yep. But I suppose that is it. That is it. And yeah, I'm pretty stoked. I can't lie. Get going!